First of all, the reason why extreme code design is necessary is because the problem no longer fits inside one computer to be accelerated by one GPU. The problem that you're trying to solve is you would like to go faster than the number of computers that you add. So you added, 10,000 computers, but you would like it to go a million times faster. Then all of a sudden, you have to take the algorithm, you have to break up the algorithm, you have to refactor it, you have to shard the pipeline, you have to shard the data, you have to shard the model. Now, all of a sudden, when you distribute the problem this way, not just scaling up the problem, but you're distributing the problem, then everything gets in the way. This is the Amdahl's law problem, where the amount of speed up you have for something depends on how much of the total workload it is. And so if computation represents 50% of the problem, and I sped up computation infinitely, like a million times, I only sped up the total workload by a factor of 2. Now, all of a sudden, not only do you have to distribute the computation, you have to, shard the pipeline somehow, you also have to solve the networking problem because you've got all of these computers are all connected together. And so distributed computing at the scale that we do, the CPU is a problem, the GPU is a problem, the networking is a problem, the switching is a problem, and distributing the workload across all these computers are a problem. It's just a massively complex computer science problem. And so we just got to bring every technology to bear. Otherwise, we scale up linearly or we scale up based on the capabilities of Moore's law, which has largely slowed because Dennard's scaling has slowed.
I'm sure there's trade-offs there. Plus, you have a complete disparate disciplines here. I'm sure you have specialists in each one of these: high bandwidth memory, the networking, the NVLink, the NICs, the optics and the copper that you're doing, the power delivery, the cooling, all of that. I mean, there's like world experts in each of those. How do you get them in a room together to
That's
figure
why
out?
my staff is so large.
What's the
Yeah.
Can you take me through the process of the specialists and the generalists? Like, how do you put together the rack when you know the set of things you have to shove into a rack together?
Yeah.
Like, what does that process look like of designing it all together?
There's the first question, which is, what is extreme code design? You were optimizing across the entire stack of software, from architectures to chips to systems, the system software to the algorithms to the applications.